Hey there folks, welcome back to another part of my thing where I am making a Tetris data extractor to extract the information from the Tetris screen as seen on the Nintendo. So this is part 10. Last time we had a huge win. It was awesome. We actually read the data from this screenshot. I should have had this ready. This one, this one, this one, this one, this one. We're almost there. So we read the screen. We read all this data. Our algorithm worked. We pulled all this information out, and we used it, and it was awesome. The difference between this and what we're going to do today is very different, because we are actually going to we're going to try our algorithm on a real screenshot. So this is an emulator that I had downloaded a while back, and playing Tetris on an emulator is not the same experience as on a CRT monitor, because everything introduces lag. So you've got the controller going through an adapter, a USB adapter, into the computer to be read by the emulator. And then the emulator draws its graphics and shows it on the monitor, which again produces some lag. And when blocks are falling, once every 3 frames, so things are going really fast, and you can't really do good. So if you really want to progress, you have to play on a regular Nintendo on a CRT monitor, which is just perfect. I mean, emulators are kind of sketchy in their legality anyway, and so the fact that in order to be as good as you can be, you have to play on a real Nintendo is just perfect. I really like that. So our algorithm used this screenshot, and we correctly got it. But now we need a screenshot from an actual game. So I've got everything set up for streaming here. All I should have to do is hit the start button on my Nintendo. So what I'm about to do is I'm about to get a screenshot from an actual Nintendo, and we will be able to see them side by side and see what we're up against. I think if I open up my capture device, I'm not sure. Play. Perfect. So here's my actual Nintendo, and I could use this controller, and I can push start. So what I'm going to do is I'm going to play a game, and then we will extract data. So let's I'm not going to play on the capture card. So the capture card will be running. I'm going to play on my TV though, and I have an audio video splitter that splits it out to both. So the one Nintendo is going to both places. So here we go. We're going to just play a quick game at level 18, and we'll go. I'm intentionally doing really bad because I don't want this to last forever. But I do want some lines. So let's get this. We'll end the day with a Tetris. Okay. So this should be good. What I'm going to do now is I'm going to hit start. And now I'm going to take a screenshot. So just all I have to do is take a snapshot. But I'll hit start after I take this. Okay, so here we go. So I've taken a screenshot. Okay. So now let's take a look at our screenshot, which I think is saved here. So this is an actual output of the game. And my concern was I think those red numbers for the statistics, I think they're going to be problematic, especially a 4. I want to play until a 4 appears in this statistics box. Because I think that's going to be the problem one. And when you see it, you'll know what I mean right away. So yeah, we'll just play until we get a 4. This time I'll try and play a little better. Have we gotten a 4 yet? There's a 4. I see a 4 already. Okay. Let's go video. Take snapshot. Here we go. Okay. But I only have 760 points. Doesn't matter. I have my 4. You know what? Let's play an actual game. This is just me having fun now. Let's play an actual game. And then we'll build up a series of screenshots that we can use. Whoops. Gonna build up for the Tetris here. Can we do it? No, we can't do it. Well, that's okay. Take snapshot. Okay, so there we go. Boy, that was a pitiful score. But hey, I got 4 in the long bars there too. Okay, now it's enough. Turning off the Nintendo. Nintendo turning off. We've got our screenshots we're going to use. Okay, now we're going to take them all, and I'm going to bring them over to my second monitor, because as you recall from last time, I'm doing this in Windows. So let's start Windows up. So the exciting thing will be how our algorithm runs. We might not need to make any modifications to it. We will based on the size, for sure. Okay, I'm just going to open up I have this shared folder. If I copy these things to my shared folder in Linux, they should pop up here in Windows. Okay, that's what we got. Okay, so we are going to use this image. Now this image is 720 by 576 pixels. So I'm going to have to write that down. This is not the number of pixels of an actual Nintendo either. The capture card is increasing the resolution a bit, but that's okay. The resulting program will have a we'll have to make it configurable, like what are the dimensions of your Nintendo screen. So that's what we'll have to do. But for now, this is okay. You recall the emulator screenshot was like 1411 by 1080. Okay, so this is what we're using. Now let's go back into Visual Studio. And the first thing we have to do is make this, make sure we can use the sizes, different sized image. Because if you'll recall, our algorithm for extracting different parts of the screen relied on pixel values. We don't want pixel values anymore. So I think what we're going to do is we're going to turn it into a percentage. All right, so this was our test last time that just worked, and we were so happy because we used this screenshot, same screenshot we opened up as the the emulator screenshot. We took this and we read it, and I was super pumped. So now we are going to have to figure out how we can make our algorithm not resolution dependent. Excuse me. So let's collapse all of this and go into our various algorithms. So digit recognition, first we reduce the image, then we compare it to canonical images, which are here. Now these canonical images are how big? I think they were 32 by 33, somewhere around there. Now, this is what it's going to be for the emulator screenshot. Now, for the Nintendo screenshot, this is going to be smaller. So what I want to do is actually decrease the size of images until they match. So I need to scale images. I need the ability to scale an image. I preferably scale it down, but scaling it up would be fine. So my question is, the first thing I've got to deal with is that built-in functionality to scale an image? And the fact is I have no idea. So I think we have this folder called image manipulators. I have my image reducer, which decreases the black pixels around it. It constrains the bounding box. Let's add another one. Oh my word. Did you guys see that? Right click, add machine learning. This new version of Visual Studio just adds machine learning. I suspect there's more to that, but that's pretty awesome. One day I'll click on that. Sorry, not a new folder. We don't want a new folder. This will be image scaler. This will be an interface. Okay. So the way I imagine this working is I will return a bitmap, scale image, and I'm thinking all I'm going to do is specify a width. Whoops. So bitmap original, and then int new width. I don't, well, actually, no, we can do this. We'll just do that. Scale my image. Okay, so how do we scale an image? That's a good question. Let's see. Because I never did this before. I don't know. Let's look at what the methods are on a bitmap. Well, actually, let's just hit F12 on the bitmap like this. These are all the things we can do from a bitmap. We can clone it, we can get a pixel, we can set the resolution. Now, I don't think setting the resolution is what I think it is. Let's have a look at the internets. Okay, this is a person from 2013 who wants to get the scale factor, bitmap. What? Wow, you guys, that's awesome. The Bitmap Constructor has resizing built in. That's kind of, oh, and there it is right here. Bitmap, original, width and height. Holy crow, that's great. Okay, actually I should look at the what's on an image. Probably not as useful things. But okay, so we can actually just return a new bitmap, taking in the original. Oh, it takes in a new size. That's okay. New size, new width, new height. Okay, so that's going to actually scale the image up or down. I think it doesn't matter. It can go either way. When we're doing pixel calculations, we really want to reduce it, because increasing an image's size causes the algorithm to insert pixels where pixels didn't exist. And when we reduce it, it's not adding any new information. It might throw out, it will throw out existing information, but it's not going to add any new information, which I think is more important, keeping only original information. Okay, so anyway, this wasn't that crazy. But again, if we need to change our scale image method, we'll just do it here. Okay, so we have our image scaler. Let's go to our screen recognition, our screen reader. So we can get a digit. That's fine. Actually, we might just use the scaler to increase it. Okay, let's do this. What's 1411 divided by 45? There's a calculator. I can do it. It's 30. Okay, I'm going to assume it's 32, because that's a nice number. I feel like I've done this before. I'm going to assume 32 characters across. So if I take the width of my screenshot, okay, I'm going to rename this screenshot to emulator screenshot 1. Oh, No. What am I doing? It was our data extraction. Yes. So here we have a screenshot. We're going to call this an emulator screenshot 1. The data extractor test will go emulator screenshot. Get all data. Emulator should get all data. Get lines. Emulator should get lines. And now I'm going to do another test. Let me bring in my oh. Let me bring in my screenshot. So this will be called Nintendo screenshot 1. Okay. Then I'm going to copy this test. We're going to throw it here. And this will be the actual Nintendo. Okay, so now I can run this on the Nintendo. So the first thing we're going to do is this Nintendo is too small. And it's also got black borders around it, see? I don't know if you could see that. This is the screenshot. We've got black borders. And so this is kind of why I thought we might use the image reducer. So I think we're going to reduce this image. So, okay, so the first thing we're going to do is, okay, go to the data extractor. When we're getting all the data, instead of just getting it first, we're going to say bitmap equals, and now I'm going to bring in the reducer. Read only image reducer. Yeah, we'll do that. We're going to reduce it. Okay, so that'll get rid of the black borders around things. Not perfectly, but hopefully perfect enough. Okay, and then we are going to need to do some calculations here. So when we got the score, for instance, we got the value at 1054, 268, and 6. This was based on the emulator screenshot, which was a 1411 by 1080. Okay, so after we are done getting reduced, we should be at something entirely different. But just based on our 1411 1080, we should be able to define relative pixel values rather than absolute pixel values. So that's what we're going to do. So we are going to say private decimal. Now this is going to be a ratio. It's going to just be a constant value. Const. What I'm blanking on the what I want. This is going to be a constant that's used to convert conversion. Just call it ratio. This is 1411 divided by no. This is not a constant. Here. When we get all data, okay, that's fine. We might turn this into a factory at some point. Okay. We're going to say 1411, and we're going to divide it by the bitmap's width. Okay, so this will give a constant, no, let's say the bitmap width divided by 1411. Okay, so now instead of 1054, we'll multiply it by the ratio. And instead of 269, we'll multiply it. We shouldn't. Here, let's call it X scale. Bitmap height divided by 1080. Okay. This is X scale. And what was it? 269 times Y scale. What in the heck? Why does... Oh, okay. This is an M, which will cause a squiggly line there. 1054. So what we're going to do is the value is going to take decimal values. Nah, not decimals. That's passing the burden here to somewhere where it shouldn't. Here. So what we're doing is we're saying, yes, I know it's a decimal value and it's got lots of you might have places under the decimal sign, but that's okay. Let's just convert it to an integer. I believe it's done. Actually, round to nearest integer. When you cast something to an integer and it has decimal places, it usually just chops it off. So here's a math.round. Whoops. Because if something's like 26.3, I want it to go be 26. But if it's 26.9, I don't want it to be 26. I want it to be 30. So we're actually going to say math.round here. Okay. What's wrong with this? Cannot convert from decimal. Oh. Because even though it's rounding to the nearest integral value, it's still a decimal. Okay. math.round. That's fine. That's what it wants to do. That's what it can do. And then we'll get 6 from there. So, okay. So that's how we get the value. Now, that's the score. We're going to have to do this with each one. But let's just deal with the score. So what we're actually going to do is we're not going to worry about any of these. Okay, we're going to take all of those away because those might throw exceptions. So when we read a screen, we're going to reduce the image, and then we're just going to calculate the score. And we'll do that by calculating the scale on the X and the Y axis. And yeah, so if the image is 1411 wide already, X scale will be 1, and this will become our original one. But in our case, since it's going to be smaller, we're actually going to get a different pixel value, but it will be relative to the size of the image. So that's good. That's what I want. Okay, let's make sure we've got no build errors. And let's try and see. No, that's the emulator screenshot. We don't want that. The Nintendo screenshot. So the score, I'm hoping, will be 29,263. Okay, let's see if that works. So we'll open that. We'll do that. So this time, I'll just comment all that out. Result.score should be 29,263. All right, folks. This is where it might not work. So let's just run it and see. I very much don't expect this to work. Parameter is not valid. Oh, did I not? Oops. I didn't copy it to the output directory. Okay, let's try again. Object reference is not set to an instance of object. Okay, so we've got a null reference error. So something is seriously happening. That's bad. So we're going to debug our test. Oh, I know why. Huh. Because we've added an image reducer, and I never set it to anything. Image reducer. Image reducer. Image reducer equals image reducer. Okay, so now it's actually a thing. And now in our tests, we're going to have this. There we go. So many new things. Oh, yes. We'll need it in this one too. And again, ideally, this is not a unit test. This is more of an integration test, but I just want to see it working. Okay, good. Let's rebuild this solution now. Rebuild all succeeded. Okay, let's do it. Let's run it. Come on, green check mark. Out of memory? What? Out of memory? Out of memory. So that doesn't usually mean your hard drive space. That's usually referring to your RAM. We don't get those kinds of errors in 2020. This is a virtual machine and it has 8 gigs of RAM. Okay, well, that's when we debug. So usually this will happen when you have an infinite loop. But I don't see where the infinite loop would be. So reduce image, bitmap. So its width is only 677. Its height is 574. It's because we've gotten rid of some of those black pixels around it. Okay, let's go into score. X scale. Y scale. Okay, 0.479, 0.531. Let's go into, so the screenshot, 677 by 574. The X, come on, what's the X? 506, and the Y is 143. Oh, the number of digits. Oh, I know why. Okay, because I have an X width here of 45 and a Y height of 39. This was the original size of 1 digit in our emulator screenshot, but these are no longer real. So we're gonna, okay, we are not gonna use these. We're gonna say X width equals, yeah, so this will be an integer. And again, do I want to make it an integer? I'm not sure. I mean, it's got to be an integer, but I don't know if I want to keep the decimal places or get rid of them at this point. Anyway, that's okay. Let's take 45 and we're going to need to make the exact same calculation here. A little bit unfortunate that we have to do it in 2 places. I'd like to clean that up. Screenshot width. Because everything was based on our emulator screenshot. So now the size is integer of math.round X width right. So we can actually do this. x width times x scale. And then the integer of math.round y width times, y height times y scale. Okay. Need another one there. So, okay. Get rid of that window. Okay. Might need a little cleaning up, but that's okay. And I'm using them here as well. Okay. Bar character height equals, this is what I'm going to do here. Character width equals character width, character height. Okay. And this is character width. Oops, yeesh. New size. Character width, character height. Okay. Yeah, that's okay. Oh, no, wait a second. Oh yeah, no, that's right. That's right. Okay. So this should work. We've made a number of changes. And so I'm actually going to run let me run my emulator tests, because there's no point in trying to make the other ones work with the modifications if the emulator one doesn't work. Okay, let's not do score though. No, let's do score. It'll be fine. It'll be okay. Up. What was that for? Okay. Let's go back here. Let's run the emulator one again. So this is just the emulator screenshot, which did work. Still works. That's good. That's the whole nice point of tests. You can verify that your existing code works. Okay. Now let's run this. And again, I'm gonna get rid of everything but score here. I'm just scared. I want to see one thing work. I want to see the score work. Once the score works, then I'll inch forward with a little bit more confidence. Oh, no. Out of memory. Where's that coming from? That is so weird. Okay, let's debug it. We're still getting the out of memory error. That is bizarre. Oh. Okay, we reduced the image. Let's go into the score. So the width is the width is 677. So we have scale factors. And now we're going to go into get value at. Okay, X value 506, Y value 143. And we're saying that the character width instead of 45 is now 22 and the height is 21. Okay, so that's fine. Crop area. See, this is showing an X value of 506. We're getting a width of 132, which is 638. Is our screenshot even that wide? Oh yeah, we've got 677 things to deal with. Okay, so we have our sub image. Now, character width and character height. Digit image is 22, should be by 21. Okay. Now we'll get the digit. Oh, of course. You guys, of course. Because our now we'll reduce the image. We're now 21 by 20. Now we're going to get the probability that it's a 0 and blah, 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 blah. But the problem is our canonical images are 45. And so that tells me that our algorithm for when one image is wider and taller than another is probably kind of not working. Because this will get the canonical image for a 0. And so image 1 is our 21 by 20. That's our screenshot digit. And this one is 33 by 38. So we're definitely in the place where image 1 is taller and wider. this was the case that I was kind of scared about. There were 252 possible ways to line up those two images. And we've returned the max. The max was minus 62. So where does the... I mean, I'm just going through this. Where does the overflow happen? So it's probably it's going to choose a 4 because it's most like the 4. I'm not sure. I could pause it. Has pixel. Well, that's confusing. That's why we're getting the out of memory error, because something is running again and again and again, and it just can't figure it out. But there's no while loop going on. That's the problem. It seems like it's working. Huh. Okay, anyway, we need to fix this because this is not what we want. The canonical image needs to be reduced. And it needs to be reduced by a certain ratio. And that ratio is the original width divided by 1411. Which is X scale and Y scale. So what I'm going to do, I'm not sure this is very good, but we're going to actually add some things here. And I'm going to make them optional. So a decimal X scale equals 1.0 and a decimal Y scale equals 1.0. So these question marks, they just mean that these are nullable. They can be null. You don't actually have to supply them in the parameter list, and if you don't, it will use these as defaults. So all the existing code that uses this method will work. Okay, so now we'll say decimal X scale, decimal Y scale. Okay. Reduce the image. Right, this is the reduced digit. So now we need to pass in X scale and Y scale. Actually, these are, no, these don't need to be nullable. They need to be optional, not nullable. Okay, that's not nullable, that's not nullable. They have to be something, but if you don't supply them, they'll be 1. Okay, so I'm going to add the parameters here to this method. I'm going to add the parameters to this method. Canonical image equals new bitmap file name. Yeah, I need to actually open it up and then scale it. And file name is just a string. So, okay. Canonical image. And then we'll just... Oh no, we need an image scaler. And we'll add it here. Let's make sure scalar equals scalar. Scalar dot scale image actually, if x scale is not equal to 1 and y scale is not equal to 1. Okay, canonical image equals new bitmap file name. That's normal. If we're actually doing some scaling, then take the canonical image and scale it. And the size is going to be canonical image width times x scale. Again, I'm going to have to convert this to an integer and round it. It's a new height. Come on. So there's a bit more processing that goes on. When we need to deal with different resolutions. So new width, new height. Okay, that's done. So if we're doing some scaling, then scale it. Okay, there is no argument to blah, blah, blah. Right, because now our digit reader. Oh boy. Needs an image scaler. And at this point, these unit tests I think are never going to be true unit tests. Oh, this one needs an image scaler. Because you'd have to define fake outputs for every one of these dependencies. Scalar. Okay, that's fine. Now let's go to data extraction tests. Now that I've changed things again, let's see my emulator screenshot work. And we've just eclipsed the 1 hour mark. Well, in my recording anyway. Might be less than an hour if I remove stuff from the final video. But let's see if we can rebuild everything. And then we're going to see if our emulator screenshot works again. Because we did more tests. Okay, rebuild succeeded. Let's make sure that this still runs. Okay, it does. So that's good. Actually, I ran quicker than before. Whatever. Okay, so now everything is working. Let's go back to our actual Nintendo tests and run them. Okay, so we thought that the score should be 524,244. The expected result was 29,263. So we do have an issue here. Let's open this up. With Paint. So the problem is I want to actually see what part of the screen we're calculating. So I think I should be able to do that with some cleverly designed debug statements. So we'll get the value. This crop area, then we've taken a sub image. I want to go to my immediate window here, and I should be able to say subimage.save testing.bmp, whatever, it doesn't matter. I should be able to hit enter. So now if I go into my File Explorer, this is under the tests. I think it would be here. There should be a testing bitmap. This is the score that we think we're looking at. And that is why, look at that, we're like 1 pixel off. So if we tweak this a bit, like I'd say that's done a pretty good job at figuring out, at narrowing in on the score, but we're just not quite there. Once you reduce this image, yeah, it kind of does look like a 5. So, but we successfully, see this says 524244. 524244. We actually successfully found this to be a 2. The 2's sort of work. But that's because we're not looking at the right area of the screen. Anyway, this has gone on long enough. This is where we'll pick it up next time when we'll fix this. So thanks for joining me. Have a nice day, and we'll see you next time.